So we're given the graphs y equals 1 over x squared, y equals x, y equals 8x, and we want to revolve the region bounded by these three curves around the line y equals -1. And the way we're going to do this is by using the shell method. So for the shell method, we're going to draw our rectangles horizontally. And then we're just going to revolve it around the line y equals -1. So you can treat the line y equals -1 as the center. And the radius, well, first, before we talk about the radius, let's talk about the height. Okay, so I'm going to pull out the 2 pi here. Now, the rectangles are bounded between y equals x and y equals 8x up until this point right here. So this point is where y equals 1 over x squared and y equals x intersect. Okay, so we're going to set those equal and get that x cubed is 1, so x has to be 1. So this x value is 1. The y value is also 1 because if I plug x equals 1 into 1 over x squared or x, I also get 1. Because the rectangles are going to be horizontal, this will be in terms of y, so we'll go from 0 to 1. Now, if y is 0, the radius is 1, right? Because my center is at -1, so the distance between 0 and -1 is 1. And the distance between 1 and -1 is 2. So if I just put y here, if I plug in 0, that means the radius is 0. But I want it to be 1, so I'm going to add 1. Okay, because now if I plug in 0, the radius is 1. If I plug in 1, the radius is 2. So that seems to be working. And my height will be the difference of y equals x and y equals 8x, right? So that's bounded by these two lines. And it's going to be right minus left, and you want it in terms of y. So the right curve is y equals x, so I'm going to put y. Minus the left is y equals 8x. So if I solve for x, I get x equals y over 8. Okay, and then I'm going to have the other integral. So I'm going to continue then from y equals 1. And I'm going to go up here where the y equals 1 over x squared and y equals 8x intersect. So I'm going to set those equal and get that x cubed is 1 over 8. So that means x has to be a half. When x is a half, I could plug it into 8x. 8 times a half is 4. And that's exactly what the y value is. So that means I'm going from 1 to 4. Same idea here. Because I'm revolving around the y equals -1, at 4, my radius is going to be 5. And at 1, my radius is going to be 2. So I'm going to add 1. Okay. So if I plug in 1 in here, I get 2. And if I plug in 4, I get 5. And then it's going to be right minus left. So the right graph is the 1 over x squared, which we said, well, that one actually we need to solve for. If y equals 1 over x squared, we have x squared is 1 over y. So x is 1 over the square root of y. Minus the left is still y equals 8x, which is x equals y over 8. And so we need to integrate this. So we have 2 pi integral from 0 to 1. I'm going to multiply this out. Actually, before I do that, y minus y over 8 is 7/8 y. So I'm going to distribute the 7/8 y with the y and the 1. So that will be 7/8 y squared plus 7/8 y. And then for the second integral, I have y times 1 over root y. That'll be the square root of y, which I'm just going to write as y to the 1/2. Y times negative y over 8. 1 times 1 over root y, which I'm just going to write it as y to the negative 1/2. And then finally, 1 times negative y over 8. Now I can integrate. So I have 7y cubed over 24 plus 7y squared over 16. And then we're going to evaluate it from 0 to 1. And then integrate the next one. So it's y to the 3/2 times 2/3 minus y cubed over 24 plus y to the 1/2 times 2 minus y squared over 16, going from 1 to 4. Okay, so when you plug everything in, you get 23 pi over 3 as your answer.